Hey guys, it's Mr. Lee with another video lesson. This lesson is not really a separate section of Chapter 7, but after looking at some of the homework submissions, it's clear that we need a little bit more explanation on the latter half of 7.2, and specifically the two topics of linear transformations and combinations or combining random variables. So I'm calling this the section 7.2 addendum, and here's our two topics: transforming random variables and combining random variables. So in this section, we're going to describe the effect of performing a linear transformation on a random variable, and then we're going to look at combining random variables through adding or subtracting, so x plus y or x minus y, and then calculating the resulting mean and standard deviation of that combination. We're also going to calculate and interpret probabilities involving combinations of normal random variables. So remember way back in Chapter 2, we studied the effects of linear transformations on shape, center, and spread of a distribution. And recall that, first of all, if we just add or subtract a constant, a, okay, to each observation, that is just shifting to the left or right. So the entire distribution just shifts a to the left or a to the right. Okay, so that what are the things that are going to change? Well, the center is obviously going to change by exactly a units, and location, like measures of percentiles or quartiles or something like that, those are going to change as well. But the shape of the distribution does not change, and the spread, so the standard deviation or the variance, that does not change. Also recall that if we multiply each observation by a constant b, well, we also multiply the measure of center and location by b. We multiply the measures of spread by the absolute value of b. But the shape does not change. Okay, the overall shape does not change. Okay, so here is an example of random variables. So we have this guy named Pete, and let's just pretend that Pete's in Hawaii, in the jungles of Hawaii, and he offers a Jeep tour. It's a half-day Jeep tour to tourists, and he's not going to run the tour unless there's at least 2 passengers, and you can see that he has a maximum of 6 passengers that can fit in his Jeep. Okay, and we're going to define capital X as the random variable, which represents the number of passengers on a randomly selected day. So you can see the probability distribution is right here. So some of the days he has 2 passengers, some days he has 3, 4, 5, and 6. You can see that it's most likely that he's going to have 4 passengers, and it's not so likely he ever gets 6 passengers. Okay, and here is the histogram of that. And so you can think about what is the shape, center, and spread. Okay, but it's pretty obvious that it's unimodal with a mode at 4 and somewhat symmetric, right? And then you can also think about the center and the spread. The mean and standard deviation are right here, 3.75 and 1.090. Remember that the mean is also the expected value. So on any randomly selected day, Pete expects to have like 3.75 passengers. Remember that expected value does not need to be one of the actual values. Okay, and if you don't know how to calculate this on your calculator, check the discussion board. But real simply, you're just going to put these values into L1, put the associated probabilities in corresponding order in L2, then just do a stat calc 1var stat, where L1 is the list and L2 is the frequency list. Okay. So Pete charges $150 per passenger. So there's no discounts for if you have a group of 6. Okay, every passenger pays $150. Okay, so the random variable C, capital C, so this is a different random variable than X. Okay, but the random variable C describes the amount that Pete collects on a randomly selected day. So if he has 2 passengers, well, he's going to have $300, $450, $600, $750, $900. So these are just like 2 passengers times $150 per passenger, okay, et cetera, et cetera. Okay. Also notice that the probabilities are exactly the same as these probabilities, because these two things, if you think about them, this capital C is just a linear transformation of capital X. Okay. Notice that the histogram has the exact same characteristics as this histogram. Well, why is that? Because this capital C is just B times capital X, where B is $150. The mean of C is 562.50, and the standard deviation is $163.50. Comparing those distributions, they are identical in terms of shape and spread. So how does multiplying or dividing a constant little b affect a random variable? Well, just like we learned in chapter 2, okay, it multiplies the measure of center and location by b, and it multiplies the measure of spread by the absolute value of b. But it does not change the shape of the distribution. In the Pete's Sheep tours, those two histograms looked identical, right? All right, note, and this is a really important quiz question, test question, AP exam question that we've had in the past and will continue to have in the future in this chapter as well as on the final exam. Multiplying a random variable by a constant b multiplies the variance by b squared. And if you're still not sure why that is, it's right in your textbook on page 496. Okay, it's also back in chapter 2. Okay, so let's get back to Pete's Jeep tours. Okay, so AP Econ students, micro econ students. Okay, the amount of money he collects, what is that called? Is that his profit? No, that is his revenue, or you could think of it as his income, right? But we have to subtract his expenses. He probably has fixed and variable expenses, right? So consider Pete's Jeep tours again. So capital C is the money that he collects, right? So his revenue or his income, right? That doesn't mean this is all profit, okay? But now capital V, okay, is his profit. So it costs Pete $100 per trip to buy permits, gas, and a ferry pass. And so we've simplified, AP Econ students, we've simplified his expenses. We're going to forget about fixed and variable expenses. We're just going to say it's just a total $100 fixed expense, okay? So what is his profit, capital V? Well, his profit is just, again, a linear transformation of capital C, right? We just take each one of these values and subtract 100. And there you have it, okay? Shape is exactly identical. What did we do? We just took this entire distribution and shifted it to the left by 100 units, or $100. You can see that the two distributions are identical in shape and spread. Okay, so let's summarize. If we add A to the measures, adding the same number A, okay, adds A to center and location, but it does not change the measure of spread. And it does not change the shape. Okay, and we just saw that when we went from capital C to capital V. What did we add? We added negative $100. So whether we're dealing with data or random variables, the effects of a linear transformation are the same. So the effect on a linear transformation on the mean and standard deviation. So if y equals a plus bx is your linear transformation of the random variable x, then we know that the probability distribution of y has the same shape as the probability distribution of x. So later on in the chapter, they talked about the normal distribution. So if x is a random variable that its distribution follows a normal distribution, y is also going to follow a normal distribution, because remember, shape does not change. Okay, and the mean of x, or excuse me, the mean of your transformation is just a plus b times the mean of x. Okay, but now sigma y is a little bit different, right? So for sigma y, the a, adding this constant a, does nothing to the standard deviation. The only thing that happens here is we multiply standard deviation of x by this, right? By the absolute value of b. Okay, so let's go a little bit deeper with Pete's Jeep Tours, okay? So far we've looked at settings that involve a single random variable. So now let's look at two random variables, okay? So X is the number of passengers on a randomly selected day in Pete's Jeep Tours, but we also have Aaron's Adventures. So Aaron also has a tour, and Y, capital Y, is going to be the number of passengers on a randomly selected trip that go on Aaron's Adventures. So the total, T, we're going to define as the sum of X plus Y. So what are the mean and variance of T? Well, here's the probability distribution for X. Here's the probability distribution for Y. Now what can we do with T? So the mean of X, we already know, is 3.75 with a standard deviation of 1.090. The mean and standard deviation of this distribution are 3.10 and 0.943. Okay, here's the two different graphs. And now, okay, Pete expects, his expected value is 3.75 and Aaron's expected value is 3.10. So what's the expected value of the total for what Pete and Aaron gets in a day, on a randomly selected day for number of passengers? You simply add the two means, okay? So 6.85, okay? So for the mean, you just simply add the two means. Okay, so the expected value of the total or the mean of the total is just the sum of the two means. Okay, the standard deviation is a little bit different. Okay, and that is because when you're combining random variables, now we're taking all of the variability that Pete experiences, because Pete, even though he expects 3.75 customers per day, we know that it varies quite a bit, right? How much does it vary? On average, each day it varies by about a passenger. Same with Erin's Adventures. On average, her like what she actually gets per day, it's not just the expected value, it's the expected value, but then adjusted by this standard deviation, right? That's a pretty large standard deviation for both of them. So now when we're looking at the total is in words, the total is how many passengers do both Aaron and Pete expect to have on a day? Well, you can just add the two means, but then the standard deviations, you cannot just add them, okay? Standard deviations do not add, okay? Standard deviations do not add. Variances add, okay? Now, this is only going to work if we have independent random variables. And our textbook gives us a couple examples where we do not have independent random variables. And so you can't figure out what the variability is going to be. You cannot figure out the standard deviation, okay? But if these two variables, X and Y, truly are independent random variables, meaning however many passengers Pete has, it has no impact on however many passengers Aaron has. Now, if these Pete and Aaron are on the same island, like located right next to each other, and their trips, their adventures are, pretty similar, they might be dependent, right? Because customers might choose Pete, which means that'll lower the probability that they're going to, choose Aaron. But let's say that Aaron is on the opposite side of the island and Pete is on the opposite side of the island, and they're just completely independent, right? And they're totally different kinds of tours. Okay, maybe Aaron's Adventures is like cave tours or volcano tours, and Pete's Jeep Tours is like, jungle, terrain. I don't know. But let's assume that they're independent. Okay. So if they're independent, then we can figure out, well, what is the standard deviation going to be? Okay, and the whole key to figuring out the standard deviation is that the variances add. Now, I apologize for the quality of this video, okay, but what you're going to, the entire point of this, you're never going to have to do this by hand. This is just a kind of a reminder of how you do this by hand. You're never going to have to calculate variance by hand, okay? All you need to know is that variances add, okay, variances add. So as the preceding example illustrates, when we add two independent random variables, their variances add. Standard deviations do not add. And this is in your textbook. You should have read this and taken notes on this, okay? So what is the variance of the total? And by the way, this total t is a new random variable, which has the same shape, okay, as these other random variables, okay? So the total, the variance of the total is equal to the sum of the two variances. Okay, that's very important. The variances add. So you can't just simply add the two standard deviations. It doesn't work. You have to turn the standard deviations into variances of x and the variance of y, then add those variances, then you get the variance of t, and then you take the square root of this to get the standard deviation of t. Never add standard deviations. You will fail. Okay, so when we're combining random variables, okay, the expected value of any difference or sum, okay, and this is with the difference, is just to take the difference of the two means. But remember, variances add. You do not subtract the two variances. Okay, in this case, D stands for the difference of x minus y. And since it's a difference, then that means that order matters, because obviously x minus y is different than y minus x. Okay, so remember that variances add. Even if you're subtracting two random variables, the variances add. And why is that? Well, just think about the concept of adding two variances or adding two random variables. You're taking all the variability of x and all the variability of y. So when you combine two random variables, you're getting a third random variable that has more variability, not less, okay, more. All right. So this example didn't come out great. I apologize for the quality of this again, but here's an example. So Mr. Starnes, he's actually the Darren Starnes is the AP Stats GOAT, University of Michigan mathematician. But he likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08. If Mr. Starnes selects 4 packets at random, what is the probability his tea will taste right? Well, he's taking all the variability of each one of those 4 packets. Okay, so how do you calculate this? Well, T, well, let's go ahead and define T as the total, okay, the total amount of sugar, okay, and it's x1 plus x2 plus x3 plus x4. We want to find the probability that the total amount of those 4 sugar packets is between 8.5 and 9 grams. And we know that each packet has a mean of 2.17 and a standard deviation of 0.08. Okay, so what would the mean and standard deviation of 4 packets be? Well, you just add 4 of these together or multiply by 4, okay, which will give you 8.68. But then with the standard deviation, we're not just going to add 4 of these. Okay, we're going to square this, add 4 of those variances, then take the square root of that sum of those 4 variances. Okay, and you're going to get 0.16. And from there, it's a simple normal probability calculation. Okay, so here is the normally distributed t, random variable t, which is x1 plus x2 plus x3 plus, in other words, the total amount of sugar of 4 packets. And this is normally distributed because, remember, anytime we're doing a linear combination of normally distributed random variables, the linear combination is also going to be normally distributed. And this thing has parameters of mu equals 8.68, sigma equals 0.16. So there we go. We go ahead and draw it. We shade the region of interest. We calculate the probability of the blue shaded region, and we find that it's approximately 0.8480. And then this is very important. If Mr. Starnes selects 4 packets at random, what is the probability his tea will taste? You need to go back and answer the question. Okay, don't just calculate this probability and just leave it at that. You need to go back and answer the question. Okay, there is about an 85% chance Mr. Stearns' tea will taste right. Okay, so I don't really love that answer. I would actually, what I would coach you to do is copy this question stem. Okay, if Mr. Stearns selects four, like literally write down these words. If Mr. Stearns selects 4 packets at random, the probability his tea will taste right is approximately 0.8480. That's exactly how I would coach you to write your answer on the AP Stats exam. So there you have it. So you've learned that adding a constant a, and remember a could be also subtracting, it could be a negative to a random variable, increases the mean of the random variable by a, but does not affect its standard deviation or the shape of its probability. Multiplying a random variable by a constant b multiplies the mean by b and the standard deviation by the absolute value of b, but it doesn't change the shape. Okay? A linear transformation of a random variable involves adding a constant a, multiplying by a constant b, or both those things. And then here we have your shape, center, and spread. Okay, so if we have y is the linear transformation of x, okay, then the mu of y is equal to a plus b times the mu of x. Okay, and then the spread is not affected by the shift a. Okay, and then these are rules that you need to learn, and the key is that even when you're combining two independent random variables, if these x and y are independent, okay, even if you're combining by subtracting, variances add. That's the key thing to remember. Variances add, not standard deviations, but variances add. Variances don't subtract, variances always add. All right, next lecture, we'll be talking about binomial settings, checking for binomial settings, binomial random variables, the distribution, mean and standard deviation of a binomial distribution. Then we'll also talk about a geometric setting, how to check if something's in a geometric, if a random variable is a geometric setting. And we'll also do some binomial distributions and statistical sampling. Thanks, guys.